In this lecture, let us discuss about architecture of search engines. See, have you ever thought of how queries are processed in search engine? Whenever we type something on the search engine, then within fraction of seconds, we are getting the result, right? But internally, lot of processing happens, like indexing and querying, which are considered as two important components. They are involved behind the processing of a search engine. Okay, so let us see those two things here with the help of a diagram. So this is the architecture of a search engine. So as I said you before, there are two components behind the processing of a search engine. One is indexing and second one is querying. So let us see the indexing part first. So indexing process, it begins with a web crawling. So here you can see the web crawler where the spiders, they crawl across World Wide Web and collect the data. So the crawlers here, they'll crawl across this www World Wide Web and they'll collect the data, which are nothing but various web pages. So the data or the page content which is collected here, it is stored in the form of a database for the process of indexing. So this process is also called as text acquisition, collecting data and storing it in the form of a database. Then the collected data is broken down into tokens or keywords. So this page content is nothing but the data. So that is broken down into tokens or keywords. Fine. So these keywords are used by the search engines in creating the indexes. So why we need these tokens or why we need to break the tokens here, break the given text into tokens? Because using these tokens, search engine will create indexes. Then each keyword is associated to a particular document. Say there are 3 keywords or tokens, then each keyword is associated with a document. For every keyword, there is a document. And through indexing, the data becomes organized. So with the help of indexing, this complete data will be arranged or organized properly, and it helps the search engine to quickly retrieve particular information. Okay, so this is the indexing part. Coming to querying part. So here you can see user is providing query. So when user search anything on the search engine, a query input is generated. So then the search engine, it parses the generated query. So this query will be parsed. So search engine parses the query and searches the index for the matching documents. So it will search this index in order to find out the matched document which matches with the query. Using ranking algorithm, search engine ranks the documents. So there are multiple documents which are stored, which are associated with the keywords, right? And so these documents, ranking will be provided to these documents based on the relevance. And finally, the generated list is presented to the user with most relevant results on the top. Say these are the 3 documents. So out of them, when ranking is given, say the rank which is given to second document is 1, third document it is 2, and first document it is 3. Then based on this ranking, these documents will be provided as output to the user. So this document will be listed on the top, followed by the third document and followed by the first one. This is how the results will be displayed, or the ranked result list will be displayed as output to the user. So this is the complete search engine architecture. Let us discuss all these things in detail. So first, let us discuss this indexing process. So there are various steps here. The first is text acquisition, text transformation, and then index creation. So coming to this text acquisition. So here it identifies and stores documents for indexing. So this web crawler here, it will select and retrieve the documents to be indexed, right? So it identifies and stores documents for indexing. Then next step is text transformation. So the documents which are collected here, those documents should be transformed into index terms or features. So during text transformations, the documents which are collected, they'll be transformed into index terms or features. And finally, index creation is done. So this is step 3, index creation. So here, the index terms which are obtained in during this text transformation phase. So this index creation step, it takes those index terms and creates indexes to indexes. So why we need to create indexes? So these indexes, they help in quick retrieval of documents. So it supports fast searching. Coming to query process, steps involved in the query process, user interaction, ranking, and evaluation. So here, first user interaction means the query which is generated by the user, that query will be refined in order to display the results. Then evaluation. So in ranking phase, ranking step, it uses the query as well as indexes in order to generate ranked list of documents for the user query, right? So these are a set of documents which are generated for the corresponding query. So that these documents are arranged according to the ranking. And evaluation monitors and measures effectiveness and efficiency. So we'll see them in detail. So this is just a brief description about the query process. Coming to the first one, a text acquisition, which we saw before. So there we just saw the brief description about that. Here we'll go into the details of each and every step involved in the process. So first one, text acquisition. Here the web crawler is used, right? So web crawler, it selects and retrieves documents to be indexed. So it identifies the documents for search engine. And here coverage should be that search engine, the crawler here, it should select sample of documents, and also those documents, they should be updated every time. So web crawlers, they follow the links in order to find the documents. So here coverage is nothing but huge number of web pages. So how many number of web pages are covered or processed, and those web pages, they should be updated time to time. That is nothing but freshness. So refresh, updated, and new documents. And here we have topical or focused crawlers in order to perform this vertical search. So we discussed different types of search applications when discussing about this web crawlers in our previous lecture. So this vertical search is one application. Next, document crawlers, they can even be used for enterprise and desktop search also. So there are many varieties of crawlers customized for general web search, single site indexing, or email repositories, and so on. So this crawler performs as text acquisition, right? So once a document is fetched, it needs to be processed. And here, the document formats, they may be converted into single format. Like it can be a HTML format, XML, Word, PDF, and so on. So all these documents, they should be converted into XML format, single format. Then text encodings are standardized. So usually it can be done using a Unicode standard like UTF-8. Now, we'll get normalized documents. So these normalized documents are stored along with the metadata. So metadata means URL or list of links on the page, time fetched. So that is total time required to fetch the document. So this is nothing but metadata. So normalized documents, they should be stored along with the metadata. So document stores, it serves as a fast input to indexer and sometimes user interface also. So if you see the picture here, after performing this text acquisition, next step is document storage. So this document storage, it serves as a fast input to the indexer and sometimes for user interface also. Then after this, text transformation should be done. So where text parsing will be implemented. So just now we discussed all these things, right? Document data store, where the data is stored in the form of text or metadata. And it helps in resultless generation, fast access. So here in text transformation, parser is used in order to parse a given text. We use the doc format specific parsers to extract relevant information. So here information can be title, links, headings, any emphasized text, etc. So tokenizer, it recognizes words in the given text. So here it needs to take care of various issues like capitalization, hyphens, separators, etc. And tokenizer is nothing but a document. Here the document is converted into stream of tokens with the help of tokenizer. So tokens are nothing but individual words, right? Markup languages like HTML help with this process. So here you can see, say here the tags are used in order to specify the document elements. So overview is a document element which is specified with the help of the tag. And heuristics are used either because they are fast and good enough or because the theoretical problem is unresolved. And the document parser, it uses syntax of markup language to identify the structure. So next step in this case is stopping. That means we remove two common words and the words that serve as a syntactic rather than semantic purpose. Example, a, and, the, etc. All stop words should be removed. So this helps with efficiency as well as effectiveness also. It even hurts some queries like how can a user find information about the UK brand? So there is a UK brand, the, so in such cases it becomes a problem. So if you remove the stop words, then it will be difficult to find information about the UK brand, the. Next we have stemming. So we usually transform words into canonical form to group words having a common stem. So if you take words like computer, computers, computing, so all of them, they'll be transformed into single word compute. So these words are transformed into canonical form compute. So this also usually helps, but sometimes it even hurts. Like it is not. So this is not the exact word for this compute for these set of terms, right? So this trick is not equally useful for all languages. So benefits vary from for different languages. For some languages, it may be helpful, whereas for some others, it may not be suitable.